Hey guys, so today we're going to actually solve this circuit and we want to find the voltages at these nodes. The thing about this circuit that makes it different from ones you may have seen before is we now have a current source. Now this acts almost identically to a voltage source, the same way that the voltage source provides a voltage across it. The current source provides a current. So, nicely, we can say that this current right here is 2 amps. Now, to fully solve this system, we're going to have to create some sort of systems of equations. We're going to use one main equation for this. We're going to use Kirchhoff's current law, or nicely known as KCL. This states that the sum of currents going into a node must be 0. So, let's consider a current going in here, and exiting out here and here. So if we have this current schematic, we need to figure out what the current is going in here, and the current exiting out there, and the current exiting out there. The current in this part we all call I1. Well, it goes from the 10 volt source to this VA. Now we don't know what VA is, but we can still write the potential difference between them. So I1 is going to be equal to 10 volts minus VA. However, if you recognize this is a voltage, and remember Ohm's law, V is equal to IR. So we have to divide by the resistance value that it goes through. Exactly 1 ohm. For I2, which I'll call this one right here, we do a similar trick. Recognize that I2 is only flowing through the 5 ohm, and the voltage across this resistor is VA. So this is going to be VA divided by 5 ohms. And for I3, which I shall call this one, that is going to be the current flowing through the 2 ohm resistor, and the voltage across this 2 ohm resistor is going to be coming from VA to VB, so it's going to be VA minus VB, again, over the 2 ohm resistance value. Now, if we look at how we've drawn it, we said the sum must equal 0. But that's the same thing as saying the current going in must equal the current going out. So we can make this nice relation that I1 is equal to I2 plus I3. Now, I'll do the same thing at this node. Now this is the same current going through, so this is I3 as well. But I'll label this one as I4. And notice I actually don't need to label this one because it's already known. We know this is a 2 amp current source. So let's now find those corresponding currents. Well, we know I3 already, so we just need to find I4. I4 is just going to be VB divided by 10 ohms. And then actually we don't need to find any more. These are the only currents that are in our system because all the other ones are known. So we can do the same thing as we did here, and our second equation becomes I3 is equal to I4, and it has to be the sum. So in order for this to be a correct statement, these two are going in, this one's coming out. It's going to be a minus 2 amps. Because I4 is actually equal to I3 plus 2 amps, but this is an equivalent statement. Now what I can do is substitute these definitions into these equations. I1 is going to be 10 minus VA, which is equal to I2, 1/5 VA, plus this quantity, plus 1/2 VA, minus 1/2 VB. And then here we're going to get a similar equation. I3 is 1/2 VA minus 1/2 VB, and this is equal to So I4, 1/10 VB minus 2. What you notice is we end up having a system of equations in terms of both of them. If I simplify this a little bit more, then I'll get, so let's see, we have 10 is equal to, so 1 plus 5, 1/5 plus 1/2, that's going to give me 17/10. And then minus 1/2 VB. And this one is going to give me, let's see, 1/2 stays. And then I'm going to move this over, so 1/2 minus 1/10 is going to give me a minus 3/5 VB. And now what you're having is a system of equations which you can solve either using a matrix calculator or via substitution, elimination, your preferred choice. But the final results end up being that VA is 100/11 volts and VB is 120